So in this module, we are going to talk about volatility of a bond. So price volatility of bond. We are going to talk about several things. Some are actually not covered in exam FM, but it is very good to know about those things. So let's go through the idea first. So consider 4-year 8% bond with annual coupon sold at par value to yield 8%. Calculate price change if yield rate decrease to 6% or increase to 10%. So let's try to do this. So basically this is 8% bond. So an annual coupon sold at par to yield 8%. Okay, so we have that this is timeline. This is a timeline, and here is the time is 4-year. Sold at par, so the maturity value is 1,000, and the coupon is 8%. So 1,000 times at par 8%, which is basically $80. So you get the coupon. So first thing we can find the price. Okay, so price at 8%. So using BA2 plus calculator, let me use the calculator. So we can enter the payments are $80 and the maturity value is 1,000. Rate is the rate is 8%, and the N is 4, and then compute percent value and 1,000. Okay, so then the calculate the price change if yield rate decrease to 6%. So price at 6%. So let's use the calculator again. I can use. Let me actually reset the calculator. So you have 1,000 as future value, 80 as coupon amount, rate as 6%, 4 as N, and we are calculating percent value. So it's $1,069.30. The price at 10%. Again, I'm going to reset the calculator. So 1,000 for future value, 80 for payment, 10 for I over Y, N is 4%, and complete percent value. It's 936 and 60 cents. Okay. So now let's calculate the price change. As percentage. So this would be new minus old over old time percentage. Okay, so if I go to the 6%, under 6%, it would be 1,069.30 minus 1,000 over 1,000 times 60%. So this one would be 69.30 60%. So you can say it's 6.930. And then let's see what happened with the 10%. Under 10%, it would be 936.60 minus 1,000 over 1,000 times 100%. So if I use my calculator, 36.60 minus 1,000. So this one would be 60. So this would be a negative value actually. percentage is going to be negative value. So this would be negative 6.34. Okay, negative 6.34. Okay, so now we can discuss. Okay, so you can see that very beginning your rate was 8%. So this side yield rate increase. It's increased to the 10%, and then this is 2% difference. And then the price, new price is at here, it was 1,000. The new price was at 10%, it was 936.60. And the change, the percentage change is actually 6.34. Then this side yield rate decrease. The same amount, 2%. So it goes to 6%. The new price is 1,069.30. And the difference is actually 6.930. So you can observe that even though yield rate increase or decrease by same amount, the price increment or decrement is not same. Okay, when yield rate increase, the price change is 6.34, but when yield rate decrease, price change is higher, 6.930. So the price yield relationship, if I make a graph, and this is yield rate, and then this is price, then it's look like this. Okay, so if I come to this point, this is what? This is 10%, not 8%, and from there, if I go to 6% and 10%, the same amount, 2% difference. Okay, but then the change is different. So here you can see the slope from here to here is basically 6.930. And then here the slope is smaller than that. In here it's almost negative 6.34. Just forget about the negative sign, but you can see the number wise, absolute value wise, there are different values. So this is the relationship. So the difference, you can see that the reason you have two different price change is because of the curvature of this graph. So that's going to come up in our discussion. You can right away observe that how the price change when yield rate change is different, even though same amount it changed from 8%. So these are things you need to observe. Okay. So the relationship is nonlinear. The shape of this nonlinear relationship is called convex. So this graph is convex graph. Okay. While price yield relationship of all option-free bond is convex, the curvature would be different now from one bond to another. It is this curvature that holds the key to assessing the performance of bond and portfolio of bonds. So the curvature is going to be different from one bond to another. Remember in the calculus too, we try to measure curvature using second derivative. So second derivative of graphs can be different from one bond to another. It is important to remember that the price yield relationship we discussed above referred to as instantaneous change in the yield. Remember, there are few factors that influence the price of any option-free bond. One is price change when issuer credit risk change. Okay. So the price of bond can change for different factors. One is issuer credit rating. For example, a government can issue government bonds, but then later government is becoming default on its debt issuance. So then the bonds rate can be decreased. The credit rating on bonds can be decreased. So when that happens, the price can decrease. Okay, so for example, let's say you have a bond issued by country X with AAA rating. Okay, then the country X goes to bankrupt, and then of course this bond is going to be rated as maybe C or maybe even junk bonds. So when that happens, the bond price is going to be really depreciated because nobody really wants that bond. The other one is price change as yield change. So the market rates can be different from one day to another day. Okay, so market yield rate, interest rate. So that's basically this relationship. Okay, so when the yield rate increase, the bond price become decrease. When yield rate decrease, bond price become higher. For discount premium bonds, price change even if yield rate remains same. I mean, if the bond issue has discount or premium, then this is going to happen. Okay, so now we want to discuss a little bit of how to measure this price volatility. Okay, so this is called the price volatility. So the approach is basically using basis point. Okay, so when interest rate increase by this many basis point, the price change. Okay, so that's kind of wording. So in the industry, 1 basis point equal to 0.01%. So that means basically 100 basis point equal 1%. Okay. So industry use basis point. You will see the BP basis point to denote the increase or decrease of interest rate, yield rate, etc. So what are the properties of price volatility for option-free bond? Option-free mean basically callable or puttable or some other condition. Okay. Example. So there's no option. So one is price volatility is not the same for all bonds. So so let's say market rate today is 10%, and tomorrow it jumped to, let's say, 10.2%. So now in the market, you have different bonds. Some are going to mature in 1 year. Okay. Some are 2 years. Some are 30 years. Then the price change for these bonds is going to be different for each other. Also, you have coupon bonds and coupon-free bonds. So for that also, you are going to see the different result. So maturity-wise, coupon-wise, and then also the coupon rate, how much coupon you are going to get. So many factors going to affect. So price volatility is not same as for all bond. So it's not the same percentage. Like in here, we calculated price change for that bond was 6.34 when it go from 8 to 10. But this is only for that particular bond. If you go and get another bond with different properties, when the rate go from 8 to 10, the price change would be different number, not 6.34. Price volatility is approximately symmetric for small yield change. This is true. The reason, if you look at the curve, okay, so let's say this is 10. Then if it goes to 10.1, very close, like 100 basis point, I mean, 1 basis point, 10.01 actually. So you can see that the price change is close because you can see the two side is very close. Okay, I mean the change wise. This slope is very close to this one if they are close. Okay, if they are very if they are stay very close. Okay, so it's symmetric. So that means basically it's saying that, like, let's say if you have rate as 8%, and if you go to 8.01%, then the price change, let's say it's 0.01. It is same as when it's the rate decreased to 7.9%. 0.99%. Okay, maybe the price also going to decrease by 0.01%. So this is not true. Remember, in here we saw that that's not true. Okay, when the rate go up, the price change is smaller compared to when rate go down, how much price change. Okay. Price fold is not symmetric for large yield change. Like going from 8 to 10 is large. Okay, it's almost 200 basis point. Okay, that's large change. Okay. So it's not symmetric. For large yield change, price increase are greater than price decrease. Okay, so that means basically when you go from 8 to 10, the price decrease was smaller compared to when it goes from 8 to 6, the price increase. So that is something actually the investment managers need to be aware, because you can see that your portfolio value can decrease at higher rate when the rate decrease. Okay? It's not at the same rate. So 8 to 10, one price can increase, okay, at higher. When it goes to the 8 to 6, it's at lower. 8 to 6 and 8 to 10 at lower rate. So the last property, the property 4 in previous frame mentioned that for large yield change, price increase is greater than price decreases. This has consequence in investing. For example, if an investor owns a bond, then price appreciation realized by yield decrease is greater than the loss that will be realized if yield increase by same basis point. For an investor who short the bond, the reverse is true. The shorting means basically you borrow the bond and then you sell it in the market, then you hope to buy it back and then deliver it. Okay, so the shorting mean basically, you borrow, sell, buy back at lower price. Okay, so then the difference is your profit. And then when you buy back, you return the bond, return back, borrow. So you can do that in the market. You can borrow from someone who owns the bond. You can sell it, then you buy back at lower price and then return back the bond. But then the difference is for profit. But the problem is you can see that you let's say you sell at 10%, and then suddenly yield rate decrease to 6%. Now the bond price increase, so you had to buy back at higher price at loss. Okay, so you have to be careful with that. And the property 1 says that price volatility is not same for each bond. There are two properties of option-free bond that determine this price volatility. So one is coupon rate, term to maturity. So these two are going to affect the price volatility of the bond. Okay. So here you can find a problem. Consider 2 4-year 1,000 par value annual coupon bonds, and both price to yield 8%. Okay, so the first bond has 5% coupon, so let's write the bond. So the coupon amount is 5%. So 1,000 times 5%, which is 50. So I can find the price using our calculator. Second is so the payment are 50. Mature value is 1,000. 4-year bonds, so 4N. Rate is 8%. And if I calculate the percent, it's 964. Then the other one, bond 2, the coupon amount is, the price is actually given, is 10%. So you can find the price actually is given is 1066.24. Assume rate change so that each bond is now priced to yield 10%. Okay, so calculate the price change. So at 10%, what's the price? So let's use our calculator. So I have coupon 50, 1000 future value, 0 actually, for N, 10% for IOY, compute percent value, 841. Then here the price, let's say this one, 100 for payment, 1000 for future value, 10% for rate, 4 for N, and then compute is 1000. Actually, it's 1000 because we are taking the same coupon rate as usual. Okay, so now price change for this one, you can see a new price is 841.51. Old one is 964 divided by 964. You multiply by 100%. The other one, it's 1000. New one is 1000 minus 1066.24 divided by 1066.24 times 100%. So you get the price change as a percentage. So by 100%, it's 6.56. It's a negative number. So the other one, if you take 1000 minus 1066.24 divided by 1066.24 times 100, and this one is negative 6.2124. Okay. So you can see that this one is higher coupon rate. This one is lower coupon rate. Okay. So what happened? Basically, you had the rate at 8%. It jumped to 10%. Okay. Then the price change for bond one goes from for bond one, the price change as a percentage is 6.56. For the bond two, it's 6.21. This one is lower coupon. This one is higher coupon. Okay. So even though bonds have the same maturity, so here again I have to mention that both are same maturity. Okay. Yeah, even though they have same maturity, when the yield rate change from 8 to 10%, the price change is different. Why? Because you have two different types of coupon, and the lower coupon have higher price change compared to the higher coupon rate bond. So for given term to maturity and initial yield, the price volatility is greater the lower the coupon rate. That's what we observe here. Lower the coupon rate, higher the price change. One implication of this is zero coupon bond will have the greatest price volatility for given maturity. So that means the bond with no coupon at all, that would have the highest price change. Okay, so if you come do the same thing for bond without any zero coupon, you will find the price change is very high. All things equal, bonds trading above their fair value have higher coupon rates than the bonds trading below their face value, and hence will be less sensitive to each other. Okay, so here now we want to observe what happens if the term to maturity change. Okay, so you have the same coupon and the yield 8%. One is 4 and the other one is 8. So let's calculate the price. Bond pays interest annually, then the shorter term bond is 900. So 4-year bond. And then I have the 8-year bond. So right now price is they calculate 963. Here price is 827 and 60. Okay. So what change? Yield rate go from 8 to 10. So here the same thing, 8 to 10. So the new price, let's use our calculator and get the value. Second reset. So the coupon is 5%. By the way, this is, I think, face value is 1,000. Assume face value is 1,000. Okay, so now, so 1,000 times 5%, that's 50. Okay, so I'm assuming coupon payment is 50. You can check, I think it's actually 1,000. Then the future is 1,000. Rate is going to be 10%. This one is for 4 year and complete present value. So it's 841 and 51 cents. The same for the second one. Second reset. This time future value is 1,000. Coupon is 50. Present value what we want. The rate is now 10%. N is 8. Compute present value 733. 3 and 25 cents. So let's see the price change. So here you can see 841.51 minus 963 divided by 963. Then here the other side, 733.25 minus 827.60 divided by. So let's get the percentage. So this would be. So this would be 6.5654. And then the other one, $11.40. Okay. So this is 8 year. This is 4 year. So you can see that the coupon rates are same. And then they have the you can see the price change is higher for the longer the bond going to be mature. So that would be in here. For given coupon rate and initial yield, the longer the term to maturity, the greater the price volatility. So when the bond will take more time to mature, the yield rate change is going to affect it more. I mean, the effect in the price volatility would be more. Remember, due to credit consideration, different bonds like corporate, municipal, government trade at different yield rate on same day, even if they have same coupon maturity. When this happens, higher the yield to maturity, lower the price volatility. An implication of this is high yield bond. The less price volatility for given change in yield than T bonds. So higher the yield to maturity, lower the price volatility. Okay, so that means basically what? So that means, so this is yield rate. This is price. So you can see that, let's say this is I1 and somewhere I2. So I2 is bigger than I1. So around I2, the price change is smaller compared to around I1. If I have something like I0, I0 has more higher price change, okay, because the curvature. So that's what it means. So we are going to meet again in the next video, but let's stop here. So in next video, we are going to discuss about measuring, how to measure the price volatility of one. We discussed, but now we want to measure it more accurate way.